Welcome students and viewers. Today's class I am going to start a separate class for NET and GATE students and aspirants, and this is the demo class. You may take it. This is a demo class. And from mid-March onwards I am going to start an online and offline both classes for the NET and GATE students, as well as in these corona days almost all the universities are taking their exam online, and on online exams such small questions or the MCQs are being asked over there. So these classes could also be helpful for the postgraduate and the MBA classes where the MCQs are being asked. So this is just a class to demonstrate that we are going to start a separate and exclusive class for NET, GATE and other exams, like exams. So today's class I am going to solve few sums relating to microeconomics, in which few sums have been asked in Pakistan University. From there I have got the questions that I will be solving in the questions. So in this class I am going to solve around 10 questions, and all are mathematical questions, small questions, MCQs. Those are being very much likely to be asked in these exams, GATE and NET exams. So just I am going to start this one. First question is, this question was asked in NET 2019 probably. These two demand curves are parallel demand curves, and at constant price P1, the elasticity on two demand curves are E1 and E2. Then it has been asked that whether E1 and E2 same, or E1 is greater than E2, or E1 is smaller than E2. Look at this diagram. Once again, these two diagrams D1 and D2 are parallel, and on a constant demand there are 2 points on these two demand curves where elasticity are E1 and E2. Whether E1 and E2 are equal, or E1 is greater than E2, or E1 is smaller than E2. Third question is, this one was asked in NET, and all these are related questions. These two demand curves are very much parallel, and this is a 45-degree line. Now at these two demand curves, here E1 and E2, whether E1 and E2 is equal, or E1 greater than, or E1 is smaller than. Here this line is 30-degree, and on these two parallel demand curves we have the elasticity E1 and E2. What is the relation between these two, E1 and E2? And here this line is 60-degree inclined, and here E1 and E2, whether E1, E2 equal or unequal. So all the questions are just related to one another. And I would like to tell the students that whenever you go to solve such questions, you must look towards elasticity of demand, what it is, and what are the components or the ingredients of elasticity of demand. You must have seen that this is delta x by delta p and into p by x. In terms of calculus, this delta x by delta p could be written as dx by dp into p by x. Now it is apparent that price elasticity of demand is dependent upon three factors. This dx by dp is the slope of demand curve. This p is the initial price, and x is the initial demand. So elasticity of demand is a function of three components: slope of demand curve, secondly initial price, and thirdly initial demand. Now, while comparing elasticity between 2 points, we shall have to see that which of these components have changed and which of these components are constant. Now come on here on this diagram 1. Let me erase it, then I'll be able to write down. E1 is dx by dp into p by x. P is P1 and corresponding demand is X1. And E2 is dx by dp and p1 by x2. Now it is obvious from the diagram that on these 2 points, out of 3 components of velocity, 2 are very much constant. These 2 are demand curves, so slope is constant. At both demand curves, initial price is P1, so P1 is constant. Only on these 2 points, this initial demand has changed. For E1, initial demand is X1. For E2, initial demand is X2. And demand is in denominator, so larger the denominator, smaller will be fraction, so E1 is greater than E2 as X1 is smaller than E2, so this one will be the answer. Now when we come down over here, once again P2, P1, E1 is dx by dp, p1 by x1, and e2 is dx by dp, p2 by x1. On these 2 points, only price has changed, slope and demand remaining constant. So slope remaining constant, this demand remaining constant, only initial price has changed and price happens to be in the numerator. So larger the numerator, larger will be elasticity. So E1 is smaller than E2 or E2 is greater than E1. Now in this case, here it is 45-degree line. At E1 and E2, slope of the demand curve is constant. Since it is 45-degree line, so when we move from E1 to E2, then proportionate change in price and proportionate change in demand both are equal. So E1 dx by dp and say P1 by x1, P1 by x1, and E2 is dx by dp, P2 by x2. Now proportionate change in demand is exactly equal to the proportionate change in price. So this ratio remaining constant, so E1 would be equal to E2, no change in elasticity if this is at 45-degree line. Now with this diagram, it is 30-degree line. So definitely displacement of on x-axis would be much larger. Displacement on this axis would be much larger than the displacement on price axis. That's why, and since demand is on denominator, this has risen on a faster rate, so E2 is smaller and E1 is larger. So E1 is larger than the E2. And if it is on 60-degree line, displacement on price axis is much larger than the displacement on the output axis. It is very much apparent. So, and price happens to be in the numerator and demand in the denominator. So this E2, where E2 is greater than E1. So this is how you can solve all these questions having such diagrams. This one was asked in 2019 probably. First question was this one, and all these 4 variants are related to this one. So be careful, and whenever you go to compare elasticity between those two points or on just 2 demand curves, you have to keep in mind that elasticity of demand is a function of 3 ingredients: slope of demand curve, initial price, and initial demand. And just by comparing and analyzing those all ingredients, you can well compare elasticity between those all points. So this is all for this. I am just showing another question. This question is that a perfectly competitive firm has its total cost TC function given, then find the firm's long run competitive price. A little bit ticklish question. Cost curve is given and the long run competitive price has been asked. So unless and until you are well sound in theory, you just can't attempt such questions. For this, for finding answer of such questions, you will have to go the long run equilibrium of a perfectly competitive firm. Now you see, minimum of LAC happens to be the price of the competitive firm. So competitive firm price would be minimum of LAC. So the minimum of long run average cost curve, this is the minimum of AC, and this happens to be the price of the competitive firm. So for finding price of from this cost function, you will have to minimize the long run average cost. From finding this long run average cost, then it should be minimized, and at the minimum of LAC, the value of LAC would be the price, and it is going to be 27.5. Now let us see how it happens. TC is x cube by 10 minus 3x square plus 50x. Hence average cost TC by x is x square by 10 minus 3x plus 50. Now this AC has to be minimized. So for minimum, DAC by dx 0, that is 2x by 10 minus 30. So 2x is 2x by 10 is 3. So 2x is 30, and hence x is 15. Yes, at the production level of 15, LSA is going to be minimized. So the long run price is minimum of AC, LAC, and for this, in AC curve, this x15 has to be supplemented. So x square by 10 minus 3x plus 50, 15 has to be squared. So 22.5, rather it is 225. 15 squared 225 divided by 10, it is 22.5 minus 3 into 15, 45 plus 50. So this is 22.5 plus 5, and it is 27.5. So long run price is going to be 27.5. This is the answer. Here these two things have been asked, that delta R by delta P is Q into 1 minus C, and delta R by delta Q is P into 1 minus 1 by E. A little bit algebraic work. TR is P into Q. So delta TR by delta P, that is dTR by dP, U into P differentiation. So 1 into Q plus P and into dQ by dP. Now this Q could be taken as outside. So 1 plus P by Q dP by dQ. Now since dP by dQ is the slope of the demand curve, which is always negative, so this plus sign will get converted into negative. So Q 1 minus P by Q and it dP by dQ. Now for the demand law, X as a function of Q as a function of P, elasticity is dQ by dP Q by P, hence dQ by dP and P by Q. dP by dQ, dQ by dP, and PR, sorry, this is dQ by dP, yes, dQ by dP, because here we have, and dQ by dP. Now it is obvious that this is 1 and this entire quantity is E, that is E. So this is Q into 1 minus E. This one is proved, because this delta R by delta P is nothing but dTR by dP. R is the sales or the total revenue at both of these places. So this is dTR by dP, and dTR by dP is nothing but MR. So this is MR. At both places this is MR. This is dr by dq. It is also MR and it is also MR. So at one places, if It is like this. If TR is differentiated with respect to P, then we get this one. Now if this is now if E is 1, then 1 by E would be dP by dQ and into Q by P. Now let us see what happens. Now TR is differentiated with respect to Q. Here TR what is with respect to P. So dTR by dQ, then dP by dQ into Q plus 1 into P. So P plus Q and dP by dQ. Now this sign must be negative because this sign is being preceded by from this dP by dQ. This is slope of the demand curve. So this is P minus Q and dP by dQ is P is taken constant 1 minus Q by P and dP by dQ, this one. So in the bracket for this could be 1 by E could be substituted. So this is P and 1 minus 1 by E. So this proof and this proof happens to be this. So this is the answer and this is how we get the answer. Now these three questions are very closely related to each other. And all these three demand functions are given, and just corresponding to each demand function, elasticity has been asked. Now, regarding these three questions, I am showing one theory. You just try to remember it. If x is any constant by p to the power m, then elasticity is m. So here elasticity would be 3. If P is a to the power x to the power m, then elasticity is 1 by m. So for this one, elasticity would be 1 by 3. And if demand curve is a rectangular hyperbola or P barabar a by x, this demand curve is called rectangular hyperbolic demand curve, and for this elasticity is 1. So this is rectangular hyperbolic demand curve and here elasticity is 1. So if you keep in memory these three things, you will be able to answer. Just I am showing one question, this one. X is 50 by P cube, function of P. So elasticity is dx by dP x by P, marginal function by average function. Now 50 by P3 differentiation. So 50 and minus 3 P to the power minus 4, and here x by P. So 50 P cube and divided by P. So minus 3 50 P to the power minus 4, and here 50 and T to the power x by P and P by x. So 4, and so elasticity is 3. So if this is in this form, then elasticity would be m if x is the function of P, and if P is the function of x, then elasticity would be 1 by m. So here answer had been 1. So keep in memory these three standard forms and you will be able to answer such questions in net whenever it is being asked. So this is all for today. In next class I will be coming with more questions, with more variety of questions, and this class will continue. In every day I will be keeping one class separate for this class. So this is all for today. We shall meet in next class. Thanks.